In this lecture, I am going to cover a new multi-threading topic called thread synchronization. And this is the act of synchronizing two or more threads together in order for them to exchange data. You've already seen an example of thread synchronization when we looked at the thread.join statement, which suspends the current thread until another thread has finished. This is a very simple form of thread synchronization. One thread waits until another thread has finished. Once the thread finishes, the other thread resumes. We can generalize this example to something more generic. Thread synchronization is the act of suspending one thread until a certain condition is met in another thread. So why would you need thread synchronization? Well, let me show you an example. This is a very common situation in multi-threaded code. You have a main thread that launches a second thread to do some complex work in the background. The thread loops and produces a new result every few milliseconds. The main thread simply waits for the results to become available and picks them up one by one. You already learned in the previous section that you can set up a shared variable to pass data between threads. And to avoid a race condition, you need to make sure to lock the variable every time when it is read or written to. So here is the code that implements my example. There is a shared variable up here, a simple integer that I'll use to pass data between the work thread and the main program thread. The thread work method is over here, with a while loop that simply loops forever. During each loop iteration, the thread does some work, which in this case is simply incrementing the variable. And then the thread goes to sleep for 1 millisecond. And then it does the whole thing all over again. The main program method is down here. The program sets up the thread and starts it, and then loops 100 times to collect the results and write them to the console. Let's pretend that the main program method also does a lot of other stuff, which I simulate with this sleep statement here that suspends the thread for 10 milliseconds during each loop iteration. Now, what do you expect to see when I run the program? If both threads line up perfectly, I expect to see the sequence 1, 2, 3, 4, 5, 6, etc. Let me run the program. And check it out. That's not a very regular sequence. And it makes perfect sense if you think about it. The work thread produces a new result every millisecond. But the main program thread only collects the result once every 10 milliseconds. So I lose roughly 10 results during each loop iteration. The problem here is that the two threads are not synchronized. Both threads are running freely, reading and writing into the same variable, and there is no guarantee that the result of one thread is being picked up by the other thread in time. So To fix the problem, we need to find a way to synchronize the two threads. What we need is some kind of simple communication channel between the two threads. Something like this. So the work thread starts and performs the very first calculation. Then, instead of writing the result into the shared variable, it sends a message to the other thread, something along the lines of, "Are you ready to receive data?" The work thread then suspends itself until it receives an answer. The main program thread enters its own loop, and just before reading the shared variable, it sends a signal to the work thread. Yes, I am ready to receive data. The work thread receives the signal, unsuspends itself, and writes the first result into the shared variable. The main program thread then reads the result from the variable, and the cycle continues in the next loop iteration. The good news is that there's a class in the .NET framework that provides this exact type of communication, the AutoResetEvent. You can visualize an AutoResetEvent as a turnstile, like you see in movie cinemas. One or more threads line up behind the turnstile, waiting to be let in, and the act of inserting a ticket lets a single thread through. A thread lines up behind the turnstile with a call to AutoResetEvent.wait1 and a call to AutoResetEvent.set lets a single thread through. Wait1 and set can be called from two different threads. I can implement the communication channel using an AutoResetEvent. The work thread asks if the main program thread is ready by calling the wait1 method on the AutoResetEvent. The main program thread, in turn, indicates it is ready to receive a result by calling the set method, also on the same AutoResetEvent. So now the work method patiently waits behind the turnstile until the main program thread inserts a ticket to indicate that it is ready. The turnstile then opens, allowing the work thread to write a result into the shared variable. Let me change my program to implement this communication channel. So what I need to do is add a new AutoResetEvent to my code. Let's call it ready for result. The work thread will use this AutoResetEvent to ask if the main program thread is ready to receive a new result. If it is not ready, the work thread will suspend. This corresponds to a call to wait1. So let me add that to the work method. So just before writing a new result into the shared variable, I call the wait1 method on the AutoResetEvent. This will ask the main program thread if it is ready, and suspend the thread if it is not. In the main program method, just before reading from the shared variable, I add a call to the set method of the AutoResetEvent. This will indicate to the work thread that the main thread is ready to receive data. It effectively opens the turnstile, which unsuspends the work thread and allows it to write its results into the variable. And that's it. These two simple modifications will allow the two threads to synchronize and effectively pass data between them, despite the fact that their loop timings do not align. Let me run the program so you can see what happens now. And there you go. A perfect incrementing sequence of numbers. Problem solved. Or is the problem really solved? Let me scroll back through the sequence of numbers all the way to the beginning. Look at this. The sequence starts at 0, then jumps to 2, and then increments by 1 as expected. What's going on at the beginning? What we're seeing here is another race condition. Until now, I've always assumed that the work thread starts right away and has a result ready before the main thread is able to pick it up. But in fact, the reverse is also possible. The main thread signals that it is ready to receive a result and then immediately reads the shared variable before the work thread has a result available. So what we need is another communication channel. The work thread first asks the main thread if it is ready to receive a result, and then suspends until it receives a confirmation. Then the work thread should write the result into the variable, and then it should signal to the main thread that it has finished writing the result. The main thread should signal to the work thread that it is ready to receive a result, and then it should ask the work thread if it has finished writing the result and suspend until it gets a confirmation. This bidirectional communication channel with symmetrical signal and ask actions at both ends is a very common programming construct. It sets up a very robust communication channel between threads. So, let me modify my code to add this second channel. First, I need to add a second AutoResetEvent. I will call this one setResult, because it indicates that the work thread has set a new result in the shared variable. Next, I need to modify the work method. After the work thread writes the result into the shared variable, it needs to signal to the main program thread that it has done this. So I'll add a call to set here, using the new setResult variable. In the main program thread, I also need to make a change. After the main method signals to the work thread that it is ready to receive a new result, it needs to wait until this new result becomes available. I will do that by calling wait1, again using the new setResult variable. And that's it. These two simple modifications set up the second communication channel and create a robust data channel between the two threads. Let me run my code to see what happens now. Here we go. And there you have it, a perfect numerical sequence. But now, when I scroll back all the way up to the beginning of the output, you can see that the sequence starts with 1, 2, 3, 4, etc. Perfect. So, what have we learned? If you want to safely pass data between two threads, locking is not enough. You also need to synchronize the threads. A simple form of thread synchronization is the thread.join method, which suspends one thread until another thread finishes. More complex synchronization can be created using the AutoResetEvent class. A call to wait1 suspends a thread, and a call to set resumes the thread. For a robust communication channel, you need at least 2 auto reset events with calls to wait1 and set at both ends.